All right, so let's actually talk about what we're observing, right? Not just these long-term cycles that we have to tease apart, but what are we actually seeing? This image is showing the change in annual average precipitation over the last 30 years compared to the 20th century. So it looks like the western part of the US is going to get slightly drier compared to the previous century. Much of the eastern portion of the US is going to get wetter, except for little splotches, including where we are at. In coastal Georgia, we are expected to get slightly drier. Actually, these aren't expectations, these are observations. So we have gotten slightly drier compared to the previous century. Now, notice this is a fairly high resolution model where we are able to see very, very granular changes, right? We see that the coastal Georgia has become drier, even though, the rest of the, or much of the rest of our state has become wetter. If we look at climate models that do not have as high of a resolution, we don't get the same results. So here are the predicted precipitation for both summer and winter in models that have lower resolution. So notice that it's kind of blocky, and Georgia is really only split up into one or two of these blocks. So that means that even though in this high resolution observational map, the coast has become drier, when you average out the entire block of Georgia and these low resolution predicted maps, it's for much of the year is showing that we will likely get wetter. Now, I don't know if that's saying that we on the coast actually will get wetter, or if it's just saying on average, Georgia will get wetter. It would require that we use a higher resolution model, which, as you know, takes a lot of computational costs and is hard to come by. But here in Georgia, we are expected to get wetter both in the summer and the winter. And the West Coast, or the western part of the US, is expected to get drier during the summer, but often wetter during the winter. All right, so what are the implications of these? So this image is showing the drought index for lots of different locations. Notice that the coast of Georgia, as we've been talking about, is in this kind of unknown zone. But we can look at the areas around us. So overall, the rest of Georgia, we expect to have fewer droughts or compared to the rest of the country, whereas out west, whereas you might expect areas that are already dry are expected to become even drier and have more intense droughts. So why do we care, right? If in coastal Georgia, our droughts, are kind of remaining the same, why do we care about droughts in the western part of the US? Well, a big reason is food, right? A lot of what we eat doesn't come from Georgia. A lot of what we eat comes from different parts of the US and different parts of the world. So we think that global demand for food in the year 2100 could increase by 59 to 98%. That is for a few reasons. A large one is that the population of the world is exponentially increasing, but also as we work towards a more equitable livelihoods and people being able to access the food they need, then even with population remaining the same, people will be demanding more and more food, right? So in the US, production of corn, much of which is used to make feed livestock and biofuel, could be cut in half by a 4 degrees Celsius increase in global temperatures, which is possible by the year 2100 under RPC 8.5. Now, 8.5 is that high-end worst-case scenario. So even if we stick to one of the lower RPCs, say 4.5, and we limit warming to just 2 degrees Celsius, US corn production could still decrease by about 18%, right? So that is 18% of not just our own food, but food for our livestock. So that could also impact our meat supply and also biofuels, impacting our energy supply and our ability to limit global warming by using biofuels, right? So just another example of how we need to understand both global changes, but also regional changes, and how each of these regions impacts the global economy, global livelihoods, global food supplies.